Hey everybody, today we're going to be doing a limit problem. The limit in question is the limit as x approaches infinity of x over the floor of x. Before we begin, I just want to remind you what the floor function is, and it's a function that essentially rounds down to the nearest integer. So the floor of 7 is just 7, the floor of 7.2 is also 7, and even the floor of 7.9 is 7. Even though 7.9 is closer to 8, it still rounds down to 7. Even something as crazy as like 7.99999 followed by like 10 nines or a million nines or something, that will be rounded down to 7. But once we hit 8, the floor of 8 is 8. So hopefully that makes sense. And this way we can kind of bound our function. So we can bound the floor of x, and then that way we can use the squeeze theorem to actually find our limit. So if we want to bound the floor of x, we can do so by just thinking what's like the maximum and minimum number that you can do so that it rounds down to like 7, for example. So if we start on this side here, we'll start here with an upper bound. The floor of x is going to always be less than or equal to x. And let me show you why. So for example, if I have 7.9, so this is x, and this is floor of x, okay? So the floor of x, 7.9, is, so 7.9 itself is greater than 7, which is the floor in this case. So 7.9 is greater than 7. So it's pretty much going to be greater than for every combination except for 7 itself, because here x is equal to the floor of x. So hopefully that makes sense there. And then let's look for a lower bound here, right? So if we think of the extreme case 7.99999, something like that, the floor of that is going to be 7. So but that's almost as far as we can go. Once we get to 8, the floor of that is 8. So that's kind of like out of our range, right? So the difference between x and the floor of x is not going to be greater than 1. So we can just think here that it's going to be less than x minus 1. Not less than or equal to, just less than, because again, the floor of 8 is 8. But anything less than 8 is going to round down to 7. So that's kind of our little inequality here. Notice how this isn't exactly the form we want. So let's basically think of how we do this. If we flip the inequality, and I'm sorry, take the reciprocal of it, so if I look for 1 over the floor of x, this is going to flip the inequality. So it's going to turn into this, and then this. I think I did that right. So yeah, because if you think about it, it's kind of like the thing where it's like, okay, well, 2 is between 1 and 3, but 1 over 2 is between, so it's going to be 1/3 here, and then 1 over 1, which is just 1. So something like this is pretty much the same thing. I took the reciprocal, and actually, I need to make this 1 over x, and then 1 over x minus 1. And then once we have that should actually make more sense now. So then what I can do from here is simply just multiply all sides by x, assuming x isn't 0, but we don't really have to worry about that because it's going to be a really big number anyway. So what we can do here, I'll just scrub this out and then write the x's there instead. And then x over x, when x isn't 0, is just going to simplify to 1. So we have this form now, and we can apply the squeeze theorem. So let me write all three of these statements with the limit in front of it. So now we have all these limits, and this is really what we're trying to find. But notice how these two limits are pretty easy, right? The limit as x approaches 1, or as x approaches infinity of 1, of any constant, is just going to give us 1. So really, I can just scrub this out, and then that's the same thing, right? Now as we go here, notice how we can kind of use the whole thing about using the highest the term with the highest power. And in that case, it's x and x here. But then x divided by x, I mean, they're the same power, so x divided by x is just 1. So again, this is going to be 1, right? So this, I can just replace this whole thing with 1. And that's pretty much it. Now, the only thing that I'm not too sure about what's happening here is the fact that, like, okay, we're definitely, like, the answer here is 1, because if we're greater than 1 and less than 1, you know, obviously we're going to end up as 1. But the thing is that here it's, you know, this limit is greater than or equal to 1, but it's less than 1 at the same time. So I feel like there should be a less than or equal to sign there, but I'm not sure how we'd get that. So for now, I'm just going to leave it like that and then just scrub past it. We're not going to worry about that. But in fact, this limit is in fact equal to 1. So I'll box this in. And yeah, so that's our answer. So I feel like that's really interesting how as we go to infinity, this is just going to be 1 in the end. So I hope you enjoyed. Thank you so much for watching, and I'll see you in the next video. Bye, guys.